Hello everyone, and welcome to this theory recording on methods of analysis. So we will now be focusing on mesh analysis. So what is mesh analysis? Mesh analysis links with KVL, which is defined as the arithmetic sum of all voltages in a loop which should sum to 0. So this implies that the voltages produced by a source or sources in a circuit must be absorbed by the resistive elements in that circuit. We express the voltages as a function of the unknown currents in the circuit, and then we solve for the currents and any other unknown required values. So we have V equal to IR, and that R can be replaced by the current Ix minus Iy. So effectively we're going to be determining the mesh analysis, and we were going to be expressing the voltage of each element. V is equals to IR, and the voltage is going to be expressed by the current or the difference in current if you have instances where the resistive element is shared between two loops or two meshes. What is a loop? A loop is defined as any closed path in a circuit, whilst a mesh is defined as any loop that does not have another loop inside of it. So the smallest form of a loop is then known as a mesh. Let's take a look at this semi-completed example. So in this example, you'd be requested to determine the currents in the loop, in the two loops, and the first step would then be to associate direction with these currents. So you can either choose the currents to go in a clockwise direction, as has been indicated in the circuit. You could also decide that you want them to move in an anti-clockwise direction, which is also acceptable. So we need to determine the currents I1 and I2. So we need to do a KVL in both meshes. So we're going to start off with KVL in loop 1. And in loop 1, we do our KVL expression. We're going to say we start off at this point. Let's call this the ground point. So it's a ground point. The current moves in a clockwise direction. We first reach the 4 ohm resistor, so that will be 4I1 minus 36 volts. We hit the negative terminal first, plus 2I1 plus 12 I1 minus I2 gives me 0. And the current here is always the reference current minus the other current. So the reference current is the current of the loop that you're doing a KVL of first, minus the other current. Right, then we can do a KVL in loop 2. And in loop 2, we're going to say 24 volts plus 3I2 plus 12 I2 minus I1 this time. I2 is the reference current because we're in the second loop, plus 9 I2 gives us 0. That will be the second equation, and this will be the first equation. And we can see from here that we will have two unknowns, which is I1 and I2. We will have two equations with two unknowns. We can then be able to solve and determine the values of I1 and the values of I2. And then following this, if there were any other additional voltages that were required, for instance, the voltage across the 2 ohm resistor, we could then say that the voltage of the 2 ohm resistor is going to give you I2 multiplied by 2 ohms. So you can use the values of the currents to determine any other additional unknowns. Thank you for watching this video and enjoy the course.